Find the volume of the region enclosed by x squared plus y squared equals 9z squared, and x squared plus y squared plus z squared equals 9 above the xy plane. So that means if we're looking at where the tip of this cone is, it's about here, and it runs this way and this way. And I'm talking about the region that encloses the cone and the sphere. So it's going to do this. It's going to look like this piece here. So it's going to look like a snow cone. So that's the shape we're actually finding the volume of. So there's the volume we're trying to find here. Now notice the cone is x squared plus y squared equals 9z squared. And one thing I want to point out there is if I divided both sides by 9, that would give me my distance of that cone, where z equals 1. So we're going to have this triple integral. And it's going to be a 1. And then we have our Jacobian, because we're going to use spherical coordinates here. That's going to be rho squared sine phi. And then d rho d phi d theta. So now we just have to figure out our bounds here. Now for rho, since that's our first one, that's going to be an easy one. Because if you think about all of the lines from the center out, it's going to go all the way up to the sphere no matter where I'm at on this interval. We could see all of these lines going from 0 up to the sphere. And that would be all the way across this thing. There's no difference here. That's what I would end up with. So that tells us then that our rho is going to be from 0 to that sphere. Now I'm going to have to understand that sphere here, and I'm going to need the spherical coordinates to show you this. And notice this here, the rho squared equals x squared plus y squared plus z squared. So notice this piece here. That means rho squared is equal to 9, which implies rho equals 3. So all of those lines, they're going to go from 0 to 3. So that's our first bound there, which is rho. Now, these are actually very simple when I'm dealing with spherical surfaces. It's very easy to do these. Now, one thing about the phi here, now remember, phi always starts from the very top, the positive z. So like I said, phi will start here, and it'll run downward all the way until that point, and that's what my phi is going to be. So to figure phi out here, I'm going to have to find out where these two surfaces intersect, and that's what we're going to need here. So to find out where they intersect is I'm going to have to plug in 1 for the other one. And what's nice about this, I have x squared plus y squared equals 9z squared. So in this one, all I have to do is plug in for this x squared and y squared. I can actually just plug in 9z squared since they're equal from the first equation. So that's going to give me 9z squared plus z squared equals 9. So then when I put my z's together, my z squareds together, that's going to be 10z squared. And that equals 9. So then I'm going to move the 10 over. So z squared equals 9 over 10 by division. And then I'm going to square root both sides. So z is going to be plus or minus 3 over square root of 10. So now keep in mind here, that'll be this point we see here and also this one down here. That would be the negative z value there. But we don't need the bottom one because it says above the xy plane. So we don't have to worry about that bottom one, just the top one there. So that means we're not going to have to deal with the signs here. So we're looking at z equals 3 square root of 10. Now we're going to use that z equals rho cos phi because we have this z equals 3/10. And we need to find phi, and that has a phi in it, and it's the easiest one to work with. out of the three, because it only has one angle I need here. Here I would need theta and all those other things. But for this bottom one, I don't need any of that. So I'm going to just plug that in now. So my z is actually 3 square root of 10. And that's going to equal my rho, which is, now think about the rho there. That rho there is going to be 3. We already know that. So that's going to be 3 cos phi. And then I'm going to divide by 3. So this is going to be 1 over square root of 10 equals cosine of phi. And then cosine inverse both sides. Then phi is going to equal, cosine inverse of 1 over square root of 10. Which we keep that way because we don't get anything nice from it as far as like pi over 6 or some nice radian there. So we just leave it as cosine inverse of 1 over square root of 10. So when I look at phi all together, remember it starts from upper z, the positive z, and it goes downward until cosine inverse of 1 over root 10. So it's going from 0 to cosine inverse of 1 over square root of 10. And your calculator is fine with that computation, so don't worry. Now for the last one here, which is my theta. Now theta is actually the easy one here, because theta, think about how that works. So for theta then, just think about my x coming in there and my z up there. In essence, I'm going to take that whole piece that I see here, and I'm just going to rotate it all the way around to fill it all in. So that's going to be from 0 to 2 pi. So that's our integral we're going to integrate now. Now we can get rid of all this other information here. So this equals negative 9 pi square root of 10 minus, or I should say plus, 90 pi all over 5. So there goes the answer for this one here. Now again, I wouldn't ask you to do this one by hand. I mean, we could, but I don't think there's a need to here. I think it's enough just to work in setting this problem up. So this is the answer. Hopefully this helps with spherical.